Have you ever wondered what secrets Mars hides beneath its dusty surface? Today, I'm revealing astonishing images that NASA doesn't want you to miss. From jaw-dropping landscapes to mysterious rock formations, you'll be shocked by what we've discovered. Let's explore Mars together. There's a lot to unpack in this one. This fascinating image from the ESA's Mars Express shows a region known as Australe Scopuli. This area is full of features that emerge with the arrival of spring and the retreat of the ice cap. First, we have the smooth top surface. These smooth surfaces are created by layers of ice and dust that have accumulated over many seasonal cycles. Each layer represents a different season, preserving a record of past climatic conditions on Mars. The smoothness indicates relatively undisturbed deposition, suggesting a calm and stable environment over extended periods. Next, check out the dark fans. These features are formed when dust is blasted out from underground gas pockets. As the gas escapes, it carries dust particles that settle in the direction of the prevailing wind, creating these dark streaks. These fans provide insight into the subsurface composition and the dynamics of Martian winds. The patterned ground features dusty polygons bounded by icy ridges or troughs. These polygonal patterns are created by the freeze-thaw cycles of water ice in the soil, causing the ground to crack and form distinct shapes. These patterns are indicative of permafrost processes and are similar to features seen in Earth's polar regions. You'll also see bright fans. These occur when ice condenses on top of the dark fans made by dust blasted out from underground gas pockets. As temperatures drop, water vapor in the atmosphere sublimates and forms a frost layer on top of the existing dark material, creating a bright reflective surface. And don't miss the exposed layered deposits. These layers of ice and dust have been laid down over many seasonal cycles, much like the smooth surfaces. However, these deposits are exposed as the surface ice retreats, revealing the stratified history of deposition and erosion. Studying these layers helps scientists understand the climatic history of Mars and the processes that have shaped its surface. Australe Scopuli offers a stunning glimpse into the seasonal changes and dynamic processes on Mars. Feast your eyes on this stunning image of Mars's South Pole, captured by the ESA's Mars Express orbiter in 2015. This captivating view reveals a landscape dominated by an expansive ice cap. The icy surface appears layered and textured, indicating the presence of different materials and varying ice compositions. These layers have been laid down over many seasonal cycles, preserving a record of Mars's climatic history. What's truly fascinating is the evidence for liquid water beneath this icy surface. Studies suggest that there could be subsurface lakes of liquid water trapped beneath the ice cap. Liquid water is crucial for the potential for life and for future human exploration. The presence of liquid water beneath the South Pole ice cap could have profound implications for our understanding of Mars's climate history, its ability to support life, and the feasibility of sustaining human presence on the planet. The surrounding regions display a mix of darker and lighter shades of red and brown, hinting at diverse geological formations and various types of soil or rock. This contrast adds to the visual and scientific richness of the Martian landscape. Another one from Mars Express. This one showcases the southern flanks of Ascraeus Mons, the second tallest volcano on Mars. Ascraeus Mons rises approximately 11 miles above the surrounding plains, making it one of the most prominent features on the red planet. The image reveals a complex network of channels and ridges, likely formed by ancient lava flows, tectonic activity, and erosion. These intricate patterns provide valuable insights into the geological history and volcanic activity of Mars. The varying elevations and rugged terrain highlight the immense scale and power of volcanic processes that have shaped this region. Studying these features helps scientists understand how Mars's volcanic landscape has evolved over millions of years. Ascraeus Mons is part of the Tharsis Volcanic Plateau, a region that hosts some of the largest volcanoes in the solar system. Understanding this volcano and its surroundings offers clues about Mars' internal structure and geologic history. Seeing a trend? This one is also from the ESA's Mars Express, and it shows the Sirenium Fossae fracture system, which is located about 1,800 kilometers southwest of the vast Tharsis volcanic region. The ground resolution of this one is approximately 14 meters per pixel. The Sirenium Fossae features are associated with tectonic stresses linked to the volcanic activity of the region. These fractures are evidence of the immense geological forces at work beneath Mars's surface. The fractures were likely formed by tectonic stresses caused by volcanic activity in the nearby Tharsis region, home to some of the largest volcanoes in the solar system. This connection between tectonics and volcanism provides valuable insights into the dynamic processes shaping Mars. This image was captured by the Color and Stereo Surface Imaging System, or CASIS, on board the ExoMars Trace Gas Orbiter mission. It shows a section of Melas Chasma, part of the vast Valles Marineris Canyon system on Mars. Valles Marineris stretches over 4,000 kilometers across the planet's surface and plunges more than 7 kilometers deep in places. The section seen here is about 5 by 6 kilometers in size. This color-infrared image combines the near, pan, and blue filters of CASIS, emphasizing the spectral diversity of landforms and sediments on the surface. The image details a blocky deposit on the floor of Melas Chasma, consistent with an eroded and exposed landslide deposit. These blocky features suggest a history of significant geological activity. Wind-blown ripples are abundant and interspersed between the blocks, indicating the influence of Martian winds in shaping the landscape. These ripples provide clues about the atmospheric conditions and wind patterns on Mars. The CRISM spectrometer on NASA's Mars Reconnaissance Orbiter revealed a variety of minerals and phases correlating with the light-toned blocks seen here, including nontronite, jarosite, aluminum-rich clays, hydrated silica, and acid-leached clay. The tan-colored ripples likely contain ferric iron oxides, giving rise to their distinctive color. These minerals tell us about the chemical composition and weathering processes on Mars. There's also evidence of the past presence of water in this region. The bright white layered materials imply the presence of hydrated calcium sulfate, possibly gypsum, which is thought to have formed through the ponding and subsequent evaporation of water that may have once occupied portions of the chasma floor. And the last one is from, you guessed it, the Mars Express. This is Aurorae Chaos, a large area of chaotic terrain located in the Margaritifer Terra region on Mars. Aurorae Chaos is characterized by a complex and chaotic terrain with a mix of ridges, valleys, and collapsed regions. Its appearance is the result of ancient catastrophic flooding and tectonic forces that shaped the landscape. This image was created using data from the nadir and color channels of the high-resolution stereo camera. The nadir channel provides a direct top-down view, allowing us to see the surface details as if looking straight down from above. Something worth noting, north is oriented to the right. This orientation gives us a clear perspective of the region's geological features. Aurorae Chaos is part of the larger Margaritifer Terra region, which is known for its rich geological history. Studying this area helps scientists understand the processes that shaped Mars's surface, including water flow and tectonic activity. That's all for this one. If you liked this, leave a comment below and you know the rest. Thanks for watching and see you in the next one.